Alright, let's do page 4 of the sample final here. So it says determine if, it should say if f of x is a maximum or minimum, and find that value. So if we write this in order, f of x equals negative x squared plus 6x plus 7, then we can see that this is an upside down parabola because of the negative. So if it's an upside down parabola, it will have a maximum, and it'll be at minus b over 2a, so that'd be negative 6 over negative 2 or 3. So that's the x value that it occurs at. The value would be found by plugging 3 in, and so if we do that, we get negative 3 squared plus 6 times 3 plus 7, so that's negative 9 plus 18 plus 7, so that's 9 plus 7 or 16. So it has a maximum value of 16 at x equal 3. The line of symmetry then is x equal 3. That's a equation of a line. It needs to be written this way. The vertex is a point, so it needs to be written 3/16. Alright, number 11. Okay, so we're going to have to do several things here. When we're trying to find that, if we think of this being, say, y equals, we have something here that has no holes. We have a rational function with no holes because none of the factors match up. So we have an asymptote at negative 5. So I'm going to draw a sketch here just to help me do this. There's going to be an asymptote at negative 5. An asymptote at 2. And an asymptote at negative 1. And each of these occurs singly. There's no squares, and so if the graph goes to positive infinity on one side, it'll go to negative infinity on the other side. So they're going to go in opposite directions on either side of these asymptotes because none of these are squared. Or to the 4th, or to the 6th. Alright, there's also intercepts, x-intercepts, that makes when this whole thing is equal to 0, and that would be when the numerator is 0, at negative 2, so the graph crosses at negative 2, and at plus 3, and at 0. So we have that. Now, we also have the degrees are equal, so we're going to have a horizontal asymptote. And that's going to happen at, let's see, x times x times x, that's x to the 3rd, and then the denominator we have x times x, which is negative x to the 3rd. So the ratio of the coefficients is 1 to negative 1, so at, which is negative 1. At y equal negative 1, that's what this graph will approach as x goes off to infinity. Now, if that's the case, I suspect that if it's got to go through here and it gets closer and closer to this, that it's probably going to go to positive infinity at this side of negative of 2. So we're going to put in 2.1 and just see what the signs are. If I put 2.1 into x in x plus 2, I get plus 4.1, so that's positive. If I put 2.1 into there, I get a negative value. And then if I put 2.1 in there, I get a plus value. So my numerator would be negative. Now let's see what the denominator is. Put 2.1 in there, I get a plus. 2.1 in there. 2 minus 2.1 would be negative. 2.1 into x plus 1 would be positive. So the denominator is negative and the numerator is negative, so the fraction would be a positive. So this goes towards positive infinity, crosses at 3 and gets closer and closer to there. Here it crosses there, and since it has to go opposite, since 2 minus x is a single factor, if it went positive infinity there, it has to go to negative infinity there, cross there, and go towards positive infinity. And since it has to do opposite, it has to start at the bottom, cross there, and go to positive infinity. And then, since it has to go opposite, it would start here and then get closer to this horizontal asymptote. So that's a rough sketch of the graph, and you could type this into the calculator and see the same thing, although not real clear unless you get the right window. But we're supposed to solve when the y values are greater than or equal to 0. Well, none of the y values on this part of the curve are positive, but this part is. So that's from -5, not including -5, up till -2 and including -2, union, or either way. Then we go the next place that it's positive, it goes negative here, positive up here. It's from -1, not including -1, oop, messed that up, to 0, including 0, union, and then that's all negative, and this is positive, so that's from 2, not including 2, to infinity. And we don't include infinity. So that's the answer to that one. Now, number 12, somehow I messed up on this, and so I've given you a problem that has some pretty ugly roots. So this is going to take a little extra room, so I'm going to write it on here. So we have 1x to the 5th plus 5x to the 3rd. Notice there's no x to the 4th. So when I do synthetic division, I'm going to have to put a 0 in for that. Minus 7x squared plus 2x. And that's what my f of x is. Alright, so I'm going to type that into the calculator. X to the 5th plus 5x to the 3rd minus 7x squared plus 2x. And I'll go zoom 6 first to take a quick look at it. And all the action seems to be happening right around 0, so I'll go zoom 4. That'll get a closer picture of that. And I may even want to look closer. It looks like it goes through 0. Now if it goes through 0, that means x minus 0 is a factor, or so just x is a factor. So let's go back and look at this. Can I take an x out of everything? And yes, sure enough I can. I can say it's x times x to the 4th plus 5x to the 3rd. If I'm taking an x out, then 5x to the 2nd minus 7x plus 2. So I've already got it down one step. But now, let's zoom in. That's 2, and enter. And now here's 1, and here's 0. It looks like it might be about a half. And I probably meant it to be a half, but I made an arithmetic error in this, so it's probably not going to be a half now. So let's find out. Second, calculate the 0. That's somewhere between 0 and 0.6. And I think it's about 0.5, and it says it's not. It's 0.4095271, and actually that's what X is. So if I quit the graph and go X, enter, you'll see more of this number, 70972. Now, that actually doesn't, I don't know what fraction that is. The only fractions that this should have for zeros, if it's a rational number, is 2 over 1 or negative 2 over 1, or 1 over 1 or negative 1 over 1, and that's none of these. So this is not going to be a rational number. It can't turn it to a fraction. So, but I need to break this down further, so I will have to use this number in synthetic division. So this is what my calculator has stored it as X, so I'll make it a different looking X because it's not these. So I'm going to put this X synthetically into, and this is going to be ugly, ugly, ugly. 1x, and I'm going to put it into this piece because I've already done taking the x out. 1x to the fourth, 0x to the thirds, 5x to the seconds, negative 7x's plus 2. So I need these numbers down here. 1 plus 0 is 1. That's easy. This x times 1 is going to be 0.409 blah 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 blah. Okay? And if I add those, I get to 0.409 and all that stuff. Then I got to take this x, this 0.409 blah blah blah, times that. So I got to take x squared, what my calculator has memorized as x squared, and put it there and add 5 to get this next number. So I'll just write x squared there, and I'm going to add 5 to it. So I'm going to take x squared plus 5, and I get the number that goes there. That's 5.167712443. Now I got to take this answer times the x and then subtract 7. So I'm going to have this answer 5.1 blah 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 x minus 7, and then add the negative 7, and I'm going to get the number down here. So that's what I'm going to type in. That answer times x subtract 7, and I get this next number to be negative 4.883681724. Then I got to take that times the x and add 2 to get this last number, and it should be close to 0. So I'm going to take it times x plus 2, and it says 0. So we've done it correctly, but we've got an ugly thing here. This was x to the 4th, so we got 1x to the 3rd plus this many x's squareds plus this many x's plus this constant. Now I need to go one more. So now I need to go back to the graph and find this other 0, which is somewhere between 0.6 and 1. So second, calculate the 0 between 0.6 and 1, and it looks like about 0.8, and it says no, 0.79, really close to 0.8. So that's my new x. So I'll make it a squiggly x or something. Anyway, that my calculator knows that x now. So I'm going to go through and do synthetic division. I'm going to get 1 times that x and add it to the old x, which is going to be a pain now because I've lost the old x. So I got to go the 1 times the new x, which is the new x, plus the old x plus 0.40952700972, and I get 1.20634 blah 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 blah. I got to take this times x, so that answer times x, and then add this ugly number up here that we have, plus 5.167712443. And I get my new number down here, which is 6.128956179. And I got to take that times x, times the x that we've got stored in there, and then add this negative, so subtract 4.883681724, and that should come out to be close to 0. And it says this times 10 to the negative, yeah, so that's 0.000, so basically it's 0. Alright, so now I've got this reduced down from a fourth to a third to a quadratic. And so I can use the quadratic formula to find the other two zeros. Oh, I never wrote down the second zero here. I should do that while I still have it in x. I have a zero of, one of them is 0. We figured out 0 early on. The next root was 0.409 and blah blah blah. And the next root was 0.796, or 797 rounded off. And now I'm going to use the quadratic formula on this. So I'm going to use the one in my program. And I'm going to type in A is 1, B is 1.206, good enough, and C is 6.129, good enough, and I get my last two answers. And if you're having trouble doing it, it's because they're imaginary. Because we don't see the graph. If I push graph again, it only hits in these three places, so the other two have to be imaginary. So if I go back to here, I see it's negative 6.603 plus 2.401i, and the other one is negative 6.603 minus 2.401i. So there are the 3 real and 2 imaginary zeros to this thing. I will not give you something this ugly on the test, but since I did give this in the sample test, I wanted to show you that you still do the same principles that you've been doing. It's just ugly numbers, and if you're decent with a calculator, it saves you a lot of typing. Determine where this function is increasing. Okay, so we can do that now. It's increasing all the way up to that point. So from, let's slide up here so you can see this. Oh, I can do it on here. It's increasing from negative infinity up to that local maximum. So I'm going to second calculate the maximum. That's somewhere between 0 and 1, and that's like, actually let's make it 0.5, and I think it's about 0.2, and it says it's at 0.177. So there's a local maximum between there and there, or it increases from there to there, and then it increases again starting from that local minimum to infinity. So I got to find the local minimum somewhere between 1/2 and 1. Second, calculate the minimum between 0.5 and 1. And I think it's about 0.8, and it says, no, 0.7 probably, 0.63. 0.638 to infinity, it's increasing. Okay. So finally, that's all of that one.